Hello everybody, welcome to the channel again, and this is the first video, and in this video we are going to talk about standard binary search implementation. Let's suppose you are given a question that you have an array, a sorted array, and you need to find an element in this array, right? You have given this target element, you need to find it, and you can use binary search. Now there are so many problems, so many edge cases which you need to take care of, right? I'll write a basic standard binary search, and I'll tell you, about all the problems which you can face when you are writing a binary search solution. So let's start with this. Okay, so here we are on our editor, and here is your problem. So the question is really very simple. You are given an array, right? And the array is sorted. Let's say this is your array. Basically, to study the binary search, we need to study all possible scenarios, right? The first scenario can be the array is of odd length and the array can be also of even length, right? Let me write it here. So basically, any one of these two can be your input, right, of the array. You are also getting a target, right? It will be an integer and it can be anything, right? Any integer which you want to search. Now, what should be the output? The output I want from you is basically the index at which the target is present. If the target is not present, target is not in the array, then return -1. Okay, cool. I think this is very much explanatory. We have all the scenarios here. We can get array of even and odd length both, and we need to return, and we are also getting a target as input, and in output we need to return the index of the target if it is present, otherwise return -1. Cool. Let me start writing the code. I'm just writing the headers. So I'm using C++. The syntax will be very simple. If you are coming from Java background, Python background, it should not be a problem for you guys. It's a very basic syntax, and I'm not going to use any fancy keywords or anything which will create any problem for you. Okay, let's start with the main function. What I need to do is I need to write a binary search function. It will take a array of integer, right? It's a vector of integer, which is essentially an array in C++. So I will just pass the array, okay? And I'll pass a target element. And let me make those arrays here. So I'm making the array. There can be two types of array, as we mentioned, array of even length. Okay. Let me define the array of even length. So 1 to 6. And I can also have array of odd length, right? And the array of odd length is simply this. I'm just increasing one more element. Okay. Now let's implement this binary search. Okay. This binary search should return an integer, which is nothing but the index of the target element. If the target element is present, otherwise it will return -1. So it will have vector of integer array, and it will have the target element. Cool. Let's do the basic stuffs. I'll have a left variable. It will be pointing to 0, and I'll have a right variable, and it will be pointing to array dot size, right? I can point it to size -1 as well as size. Like, we'll try for both of them, and we'll see if there is some edge cases which can arrive if we are using size -1 or we are using size. Okay, for now let's use size -1, and here is the standard stuff. I am using while left is less than right. So I can also use left is less than equal to right. Um, but let's start with less than right, and then we'll see what are the problems we are facing, or if it is actually right to write like this, while left is less than right. We'll see. Uh, let's define our mid value here inside the while loop. Mid will be equal to left plus right divided by 2. Now here comes our logic. So I'll say if array of mid is equal to the target element which I'm passing, then you are at that particular target. All you need to do is return the index. And mid is the index, right? Now else if wherever you are, let's say you are at array of mid, and wherever you are is lesser than the target. And if it is lesser than the target, then you need to go to the right. You need to reduce your search space in the right direction. Okay. So what you need to do is left will become mid plus one. And the last scenario, which is array of mid is greater than element. So wherever you are at a place which is greater than the target you are searching for. Then you have to reduce your space to the left side. Okay. The search space will go to the left side. In this case, right will be equal to mid minus one. Now, why I'm doing mid plus one and mid minus one is because if it is mid, it will return the target. And if it is, if the target is not at mid, then I can safely say that mid is not my answer. I can ignore mid. So I am ignoring mid in both the cases. Okay. And finally, what I need to do is return minus one. If the element is actually not present in the array, I'll return minus one. Okay. Now, let me write some cases here. So if target is present in the array, this is number one scenario. If target is greater than greatest element of the array, this is also one scenario, right? So let's say if my target is 100, in that case, it will be greater than the greatest element. So my answer is lying outside of the array. This is one of the edge cases which we should be looking after, right? And one more edge case can be if my target element lies on the left side. So it is basically smaller than the smallest element, right? Smaller than the smallest element of the array. And there are two more scenarios which we need to check, and they are also the edge case scenarios. If the target is the first element, and also if the target is the last element. This is also important. So many times what happens because of this left is less than right, left is less than equal to right, it gets stuck on the last element or the first element, and it changes its behavior, it changes the answer. So we need to check all these scenarios, and I can say this first scenario is if target is present in between the array somewhere, okay, because we are already checking the first and the last element here. So let me write the cout statements for all these scenarios. So I have written all the scenarios here. These two cout statements is basically checking if an element is, if the target is present in between somewhere. This is checking if the target is not present. That means I am checking for something which is greater than the greatest element in the array. This is if the target is not present, I am checking for something which is smaller than the smallest element of the array. And this is checking for the start of the array, which is 1 for both the arrays. And this is checking for the element, the target is equal to the element which is at the end of the array, which is the last element. For even length it is 6, for odd length it is 7. Okay, let's run the code and see if, what results it is producing. Okay, so here we are. So let's see the first scenario. If the target is present and in between somewhere, for the even length, it is giving me -1. What? It is giving me a wrong answer here. But for the odd length, it is giving me the right answer. Okay, okay, no problem. Let's see. If the target is not present, in that case, it is giving me minus one, which is correct. Okay. If the target is not present again, it is giving me minus one. Again, it's the correct answer. If the target is present and is at the start, for the even length, it is giving me the correct answer. But for the odd length, it is giving me the wrong answer. Okay. What if the target is present at the end? For both the cases, for the even length as well as odd length, it is giving me the wrong answer. So there are so many wrong answers in this case, and that basically means that this binary search is not correct. Okay, let's do some of the changes here. Let me try array dot size instead of array dot size minus one. Okay, and let's check again. Okay, it starts from here. Now, index of the target element in between is correct. So last time it was wrong, but this time it has been improved. If the element is not present, the correct result. If the element is not present, again the correct result. If the target is present at the start, it is giving me a wrong result here. Okay. If the target is present at the end, it is giving me the right result. Now, we have an improvement while we are using array.size, but the problem is we are still getting a wrong answer when the target is present at the start of the array. I think this will not work. So I think the problem might be in this while loop, the condition here. Let me try with while left is less than equal to right. And again, I'll take the size as size minus one. Okay. Uh, Let me run. Okay, let's check. So if the target is present in between, the answer is correct. If the target is not present, answer is correct. If the target is not present, answer is correct. If the target is at the start, the answer is correct. If the target is present at end, then also the answer is correct. That means this binary search implementation is a correct implementation. Okay, so let me write some notes here, which we have discovered so far. So number one, uh, never use while left is less than right. This will always produce wrong results. Wrong result. Okay. Second note, always use while left is less than equal to right. Will it always produce right result? As in, let's check. So I'm using right now right as array size minus one. What if I use array size? What will be the answer? Will it change? Let's check. So if it is present anywhere in the array, then it's correct. If it is not present, correct. If it is not present, correct. If the target is at the start, correct answer. If the target is at the end, then also it's correct answer for odd as well as even length array. That means the the factor which was deciding whether or not you will get the correct answer was not this what will be the value of right you are choosing, but actually what is this while condition. But still, we have to choose one correct answer. We have to find a general standard binary search implementation which will work on all the cases. And for now, I think we can, decide that, okay, let's use left is less than equal to right, which is a must. I think it will produce the right answer. But while left is less than right, will always produce a wrong result, right? You'll have to do some manipulations to get the right result. But in my opinion, with the research we have done here right now, what we should always use while left is less than equal to right. And with this, I would say we should also use, because we are getting right answers for uh, any value of right, I can say use right as array size -1, and it will produce me the right result. Okay, I should say correct result. Okay, so this is all for this video. I hope you have learned something new here. You have the proof here that while left is less than equal to right is the correct implementation, it will always work. We still have to get to a generalized solution for a binary search. This is just a simple standard binary search which we try to implement and see what are the problems with the basic, very basic standard binary search. Also, there are so many edge cases which you can miss. So this is the standard binary search you can always rely upon. Before you go and watch my next video of this playlist, if you happen to discover any new knowledge or gain any insight from this video, I would greatly appreciate if you could kindly let me know by sharing your feedback in the comment section. If it was useful, just you can just write it was useful, or if you have any suggestion or improvement or any feedback you want to give it to me, just write in the comment section, and I would really like to take it forward. Furthermore, if you can subscribe to my channel, it would be immensely encouraging and supportive. Thank you so much. See you in the next one.